Boyle's law in relation to scuba diving. Boyle's law is one of the many gas laws that apply to scuba diving. This law refers to the volume and the pressure of the gas. If you have any experience in scuba diving, then you would know that you shouldn't hold your breath, and Boyle's law is the reason why. Another variable that Boyle's law can impact is the buoyancy control device, also known as the vest that the diver wears. Boyle's law can be written as P1 times V1 equals P2 times V2. In the equation, the P stands for pressure and the V stands for volume. The 1 and 2 that are next to each letter, simply put, are the before and after of the volume and pressure in the particular scenario. For the examples later in the video, the unit of pressure that will be used is ATM, which is one of the few measurements of pressure. The other units of pressure include kPa and mmHg. To convert between each unit is actually quite simple. To convert from 1 ATM to kPa, you simply multiply the ATM by 101.3. To convert ATM to mmHg, just times the ATM by 760. And finally, to convert kPa to mmHg, you would go kPa times 760 mmHg divided by 101.3 kPa. Most of the time, the pressure units that are used are kPa and ATM. The gas laws relate to the diver's lungs because every 10 meters the pressure doubles. For an example, if you were taking a breath at the surface with an ATM of 1, then at 30 meters your lungs would have a pressure of 4 ATM. You would get 4 ATM from 30 meters divided by 10 meters per ATM plus the surface ATM of 1. The equation you would then get would be 4 ATM times 1 liter equals 1 ATM times volume 2. Once you solve the equation, you would get 4 liters in the diver's lungs. This is 4 times as much as they should be, and could result in severe injury or damage to the lungs. The interrelationships between the variables in the gas law are very important to know when calculating equations using the law. The variables in the law are inversely proportional, which means that when pressure, for example, goes up, the volume will go down. The same goes for the opposite, which is very important for the diver to understand. For example, if the pressure doubled, the volume would halve. When you apply this to the diver's lungs, the variables would include the lungs volume and the starting pressure of the surface, which is always 1 ATM, and the depth of the water that you are planning to go or already have been to. The law to the vest is pretty much the same thing. To apply Boyle's law to your lungs in scuba diving, you must first find everything that the question is asking from you, and what you are given. For example, if the question was to find the volume of a diver's lungs at a depth of 40 meters, if the diver normally had a lung volume of 5 liters and the surface pressure was 1 ATM, first you would look at what you have been provided with, which would be the P2 being 40 meters, the P1 being 1 ATM, and the V1 being 5 liters. To find the pressure from the 40 meters, you would divide 40 by 10 meters per ATM, then add 1 because it is the surface ATM. From here, you would put these into the formula, which is P1 times V1 equals P2 times V2. So if you input the information correctly, then you should get 1 times 5 equals 5 times V2. Now you would solve the equation by firstly solving it to 5 equals 5 V2. Then you would divide 5 to both sides like so. 5 divided by 5 equals V2. And finally, you would get 1 litre as your answer for volume at the depth of 40 meters. To apply the law to the vest is pretty much the same sort of deal. You find the information that you were given and apply it to the equation. For example, the question was, what would the volume be at 30 meters if the vest had a volume of 10 liters at the surface? Right. First, we recognize straight away what we were given. 30 meters, the volume of the vest being 10 liters, and the surface ATM, which is always 1 ATM. We now put this into the equation, and we can get 1 times 10 equals 4 times V2. When we solve the first part, we get 10 equals 4 times V2. If we then divide the 4 on both sides, we get 10 divided by 4 equals V2, which would therefore give us an answer of V2 equals 2.5 liters.